morning, students. Hope you are enjoying our online classes. In the previous classes, we have studied the first and second equation of motion. Today, we are going to derive the third equation of motion. Before starting, let's have a quick revision. The first physical quantity that we have studied was distance. Yes, distance is total path length. The path that is covered by the object. And next is displacement. It is a straight line distance from initial to final position. That means it doesn't depend upon the path followed. It is vector quantity. And third is velocity. Velocity means displacement upon time taken. And next we have studied about acceleration. It is change in velocity upon time taken. And change in velocity means final velocity minus initial velocity upon time taken. And the various terms that we have denoted are distance is denoted by S, displacement is denoted by again S but with the arrow on its top, and then time T, initial velocity U, final velocity V, and acceleration A. Now students, is there any physical quantity left that we have studied and we have not mentioned here? Yes? Yes, it is speed. Speed equals to distance upon time taken. Next, we have studied about various graphs. Let's see what information we have got from the graphs. Yes, slope of displacement time graph gives us. Yes, what does it gives us? Remember displacement time graph? Along y-axis it is displacement, along x-axis it is time. And what does its slope gives us? Yes, velocity. But if it is distance time graph, then the slope will give us, yes, speed. And for velocity time graph, remember velocity time graph? Here it is. Velocity time graph, if we calculate the slope of this, then it will give us, yes, acceleration. And what about the area? If we calculate the area under velocity time graph, then it will give us, yes, displacement. But if it is speed time graph, it will give us distance. But for velocity time graph, it will give us displacement. And next we have studied about the three equations. The first is V equals to U plus AT. And second is S equal to UT plus half AT square. And third equation is 2AS equal to V square minus U square. This equation we are going to derive today. And do you know what does these equation gives us? That is, which relation they are giving us? Yes, velocity time relation is given by first equation, and position time relation is given by second equation, and third is this V square minus U square, and it will give us the relation between position and velocity. Now before starting, let's come to the learning objectives. After the completion of the topic, students will be able to derive third equation of motion, then interpret relation between velocity and distance traveled for uniform accelerated motion, and last they will be able to apply formula for solving given numerical problems. Now let's start. Third equation of motion, also called equation for position velocity relation. In the paper it can be derived third equation of motion, or it can be derive the equation for position velocity relation. So in both cases we are going to derive 2AS equal to V square minus U square. For this, let's consider this velocity time graph. Here AB is representing uniform acceleration, and remember I told you that these equations are valid only for the uniformly accelerated motion, that is body is moving along straight line. So whether we are talking of distance or displacement, both will be the same thing. So here in this graph, area under this velocity time graph, what does it will give us? Yes, it will give us displacement, or we can say distance also. So displacement S traveled by the object in time t moving under uniform acceleration is given by area enclosed within the trapezium. This trapezium OABC. This is shaded portion. Please see here. Yes, this shaded portion. We are going to find the area and then we will equate it to the distance. Let's see how. See this trapezium? We are going to find the area of it. Let's see. Area of trapezium OABC. It is given by half sum of parallel sides multiplied by distance between them. Now here in this graph, parallel sides are these green sides. See here, yes, blue बन गई अब ये. OA equal to BC. These are the parallel sides and the distance between them is OC. So what will be the area? It will be OA plus BC, that is these parallel sides, multiplied by OC, that is this distance between them, divided by time. Now, how to find the values of these? Now, OA and BC both are along y-axis, that is along velocity axis. So, their values will be the velocities only. OA is initial velocity, so we will substitute OA as u. Then BC is final velocity, we will substitute it as v. And OC is along time, so we will take it as t. By substituting these values of OA, BC and OC here in this formula, we'll get area equals to V plus U upon 2 multiplied by T. Now, remember first equation of motion, V equal to U plus AT. From this equation, we will find the value of T and then we will substitute this value of T here and we'll derive our third equation. Let's see how. Now we can write V minus U upon A equal to T. How? We'll take this U to the left side. We'll get V minus U and then divide it by A. So we'll get V minus U upon A equals to T. We'll substitute this value here and we'll get area equals to this U plus V by 2 as such, and instead of T we will write V minus U upon A. So we are calculating the area of this trapezium OABC, that is equal to U plus V multiply V minus U upon 2A. Let's see further. Remember, area under VT graph is distance. So we have calculated the area. We will denote this area that we have just calculated by S. Let's see. S equals to area of trapezium. Now, so S equals to V plus U multiply V minus U upon 2A. Now, for further we can simplify it as, we'll take this 2A to this left side, we'll get this. Now, here we are to use some mathematical identity. Is there any mathematical identity that we can use here? V plus U and multiply by V minus U? Yes? Think over it. Yes, it is. X square minus Y square equal to X plus Y multiply X minus Y. Great. So, here X equal to V and Y equal to U. We'll substitute and we get V square minus U square equals to V plus U, that is X plus Y, to V plus U multiply V minus U. So substituting this value, we get 2AS equal to V square minus U square. This is our third equation. So third equation of motion or position velocity relation equation is 2AS equal to V square minus U square. The set of three equations are Yes, v equal to u plus at. It should be on your tips now. It is velocity time relation. Then second is s equal to ut plus half at square. It is position time relation. And third is 2as equal to v square minus u square. It is position velocity relation. So note, write this derivation in your notebook, specifying the date and heading clearly. Then in our next class, we shall learn about circular motion. Till then, thank you, stay safe.